Good day, everybody, and welcome to the session, to today's event. You are joining us at a time when we will be showing the lecture or the talk about the distinguished guest, Ms. Muofhe Tshibalanganda from the University of Stellenbosch. My name is Yaga. I will be one of the facilitators of the session. And yes, we hope you all enjoy. I will just give a few words around who the guest speaker is. Our guest speaker, Muofhe Tshibalanganda, is a research analyst at the Stellenbosch CT Scanner Facility, an open access laboratory providing non-destructive X-ray computed tomography, CT, and high-performance image analysis services. She will be sharing the story of her journey to becoming the award-winning scientist she is today. In order to encourage and empower young girls in the sciences, of course, the presentation will also provide insight into the science behind the X-ray imaging techniques she uses and the way it is used as a research scientist. It is Women's Month. It is the last day of August. And so it is so befitting that we have an event of this nature. The intention, of course, is to ensure that we make a contribution towards inspiring young learners, young girl learners especially, of school-going age. And that they've got the courage, they've got the inspiration, they've got the motivation to push on with their studies at school, especially science learners. And yes, in the middle of all that is happening with regards to gender violence, it is my feeling that every month should be a Women's Month. That these campaigns need to be campaigns that are done on a monthly basis. If you consider the scourge, and the level at which these violences continue to be perpetuated against women and children. We hope that our lecture or our guest speaker will inspire girls so that they know that in the middle of all of this, there is hope. There is a shining light, and there are people that have made it, who grew up in similar circumstances as they find themselves in today. It is also very important that young girls also know that your circumstances does not determine your future. And without taking any much more of your time, people, I will hand over to my co-presenter or co-facilitator, Mr. Hilton Tobias. Over to you, Hilton.
Thank you so much, Mr. Yaga. I appreciate the introduction. Today, my role is just to kind of initiate the program as we start this Women's Day, Women's Month, Let's Talk Science edition. We are excited to have a lecture presentation that has been done by our guest speaker that will be played now from this time on. So the lecture will be played via this platform. And we encourage everybody that is watching to engage with the lecture. And if you have any questions, please feel free to put that in the comment section. And as at 11:30, just at the completion of the lecture, we will then have a live Q&A stream with our guest speaker and a number of different school groups that will be joining us. So we are hopeful that there will be some questions and some engagement from you, the audience, on Facebook or on YouTube as well. So please feel free to do that. And I will not also take any more time. We are now going to proceed with playing the lecture. We look forward to the live Q&A session. Thank you very much and enjoy the video.
Good day. My name is Muofhe Tshibalanganda. I'm from the Stellenbosch CT Scanner Facility here at Stellenbosch University. First, I'd like to thank the organizers of this program for inviting me to give this talk, to share my journey, my education journey, and my work experience with future doctors, scientists, lawyers, actors, you name it. It's such a great privilege to be able to share my journey with you all. In my presentation today, I'm going to briefly talk about me and also give you my education history, where I went to school, what are some of the challenges that I faced through my education history, and I will share my work experience and give a brief overview of what I actually do on a daily basis, and also outline some of the achievements with you all. So a little bit about me. I'm a Venda girl from Gaba village in Venda. This is a very small village that even people from Venda, they don't even know where this place is. So it's a very small village. And I mean, I'm from Venda, as I've mentioned, and we known for Mobango wine and a lot of fruits. But actually, we have a lot more to offer. We have some of the best schools in South Africa, and we have a lot more to offer. I normally joke with people and say that I can actually go to like 6 different countries before I can reach Stellenbosch. I can go to Zimbabwe, Mozambique, Eswatini, Lesotho, Botswana, and Namibia before arriving here in Stellenbosch. So it's like 1,947 kilometers away. But we actually have a saying in my culture saying "Kurendusi na wow." So you can go anywhere because there's always people wherever you're going. So this is my education history. When I was preparing for this, I realized that I actually went to 2 preschools, 2 primary schools, 2 high schools, and I studied in 2 universities. But actually now I'll add the 3rd university, which is Stellenbosch University, where I'm pursuing my master's. So first I will speak about my preschool. This is a very interesting picture of me. This was in 1998. This was my cousin's preschool graduation. As you can see from my face, I was not that happy. The reason was me and my cousin were born in the same year, 1993. And in 1998, she was graduating to go to grade 1 and I was staying behind. So during the entire graduation, I was asking my mother, why am I not, graduating because we're born in the same year? But the system at the time would only allow like from kids born in January, from January to June, to proceed to the next grade, and those born from July to October to proceed to the next grade the following year. So I was born in October, hence this angry face. However, I'm sharing this with you because this is one of the pictures that me and my family, we always go back to say, you know what, you've always loved education and you've always loved going or advancing in your education. So this is just a little funny story that actually all the time encourages me to go or to go further just for this little girl. So eventually, after I graduated preschool, I went to a private school called Hagai Combined School. This was in 2000, and unfortunately for me, this was a time where half of the year we were experiencing severe floods. It was at the time where we didn't have tar roads, and I needed to commute about 80 kilometers every day to get to school and also go back home. So this was very challenging, although I was very young. I just remember that we would take a school bus and sometimes would be stuck along the way and we'll need to transfer to another bus or another taxi, and I would arrive to school late, being punished for arriving at school late, and I was very young. And my parents always remind me that the only thing that they made me, or the decision that they took to move me to a different school was, I told them that, listen, when I'm sleeping, I can't even count until 10 until you guys actually wake me up. So they felt very bad. And the following year for grade 2, they sent me to Tomani Primary School. The good thing was this was a 15-minute walk away from home, and I didn't need to wake up at 3:30 so that I can catch a bus at 4:30 to go to school. So this is where I actually did my grade 2 to grade 7. However, being at this school, because everyone had established friends from grade 1 and from preschool, I was like now a new person who doesn't know anyone. So that subjected to a lot of bullying throughout my primary school years. However, I did find friends that we would encourage each other, stick together, and we actually were able to obtain high marks as we went from grade 3 until grade 7. And at the time when I graduated, or I passed my grade 7, I was awarded with an award for being the best grade 7 learner in our district. So that afforded me an opportunity to actually go to one of the best schools in Limpopo and also in South Africa, which is Chibasa Secondary School. Although this was not my first choice, I wanted to go to Mburi Secondary School, as it's the best school, one of the best schools in South Africa, producing 100% bachelor pass for years. However, I didn't manage to get into Mbiri Secondary School. So I did my grade 8 to grade 10 at Chibasa Secondary School. This was approximately 60 kilometers daily commute to the place. So again, now I was back to traveling from waking up at 3:30, 4:30 to take a bus, at 5:30. Sometimes I'll need to take a bus at 4:30. And then also the school would finish around 3:30 and then take a bus back home. So I'll get back home around 6. And yeah, so now when I share the story, people are like, yeah, but you were waking up so early. For us, it was quite normal because the best schools where I'm from were quite far. So you need to sacrifice to wake up early and also get back home late. However, when I was in grade 8, to my surprise, the first time when I wrote exam, we were about plus minus 280 in grade 8. I took position 3. And to be quite honest, I was surprised. Like, oh, okay, took position 3, but that was actually quite great. So throughout from grade 8 to 10, I was always in the top 10 competing with other students, for position 1, 2 to 10, because that was considered like the top achieving students at each grade. So in 2011, finally, I enrolled at Mbiri Secondary School, and I did my grade 11 and 12 at Mbiri Secondary School. This was around 71 kilometers, like a daily commute of 71 kilometers. So now waking up early was not new to me. And at the time when I passed my grade 12, we were around 421 in our grade 12. So you can see that this is quite a big school. I mean, if the entire school has plus or minus 2,500 learners and around 80 teachers, you have to be serious about your education, in a sense that you need to take your own initiative to actually learn, because teachers don't have that one-on-one. They can't see your weaknesses, they can't see your strengths. So this is where, or at this school, where you get to learn to be your own self. You have to learn to be comfortable asking other learners, asking the teachers what you don't understand, because if you don't, you will be left behind. And also, maybe I'll just mention that I think the school, the name of the school will ring a bell with most of you. Mburi Secondary School. The school was in the news. I think it was April this year for, unfortunately, a grade 10 learner who committed suicide due to bullying. And I just wanted to actually say that was very unfortunate. But speaking from a young woman to other young women, is that in this world we have each other. And it's our responsibility as girls, because we know that she was bullied by other girls in her school, that it is our responsibility as girls, as we are growing to be young women, to actually be our sisters' keepers and also our brothers' keepers, to actually love one another and not ridicule other children, because it was quite unfortunate that she was a top performing student who unfortunately commit suicide. And also as a victim of bullying, it was very personal for me to actually say it's not up to teachers to punish bullies. It's up to us to actually stop bullying as it starts, because we are the ones who know what's happening before even our teachers know. So I'll just encourage that as we are growing up, becoming young women, is our responsibility to be our sisters' keepers and our brothers' keepers. So after I matriculated, I went to the University of Free State. I've always wanted to be a geologist, because I'm from a village in rocks where what I would see. We have a beautiful mountain, and I've always been interested of how this mountain came out to be. So studying geology was the one thing that will answer the questions that my parents didn't have answers to. So I enrolled at the University of Free State to study geology. Unfortunately, due to some personal circumstances, I couldn't continue with geology at this university. However, I moved and I did my second year up until my honors level, still doing geology, but now with added geography to make it geoscience. So I studied geology and geography from second year to honors at the Nelson Mandela University. At the time I was there, it was Nelson Mandela Metropolitan University. And the time I was there, the place was called Port Elizabeth, now it's called Gqeberha. I mean, we all have to learn Gqeberha, but yeah, I did my second year to honors year. It was a great time where I got to meet different people, where I got to stretch actually my personality. I'm more on the introverted side, but I had to learn that, you know, in order to learn, in order to be out there, you need to know how to speak for yourself. You need to know how to actually, you know, speak to lecturers, speak to other students. As you can see here, this was my honors year, where I was trying to show the class that, you see, this mountain was formed this way. This is how it looks like this. But this is where I had the greatest time. I met some of great friends that and some of the greatest researchers in this world. I met them at the Nelson Mandela University. So I graduated with my BSc undergrad in geoscience in 2016. This is me and my graduation with my family. One thing about Venda families, they show up. So all the way from Venda to Gqeberha, this was my family at my graduation. And then the same year I graduated, I was busy pursuing my BSc in honors, honors in geology. And this was my graduation in 2017. I graduated with a BSc in honors. And again, my family knows how to, to show up at those graduations. However, after completing my BSc in geology, it was a time that the mining industries were not doing well, and I opted to actually volunteer at a high school in Secunda. The reason why I was there was there's a lot of mines, so I would be marketing myself, applying for jobs, while at the same time I am assisting high school learners from grade 10 to grade 12 with their maths and science. And that was quite interesting for me to be able to give back to my community, to be able to assist more students. And also during the course of my university year, I started a foundation where we assist, because I'm from a very small village, to assist children that are from backgrounds where their parents can afford to buy them uniforms. And also for high school, then we would help them with their career choices, with some of the experiences that we learned, and also to open them to more opportunities. Because when you're from a very small village, you're limited to different opportunities because you don't actually know that much. Your world is not open to that. So after having the opportunity to go to university, I then learned about other professions, and then we will go home during school holidays with some of my friends, and we will organize that we meet and we share different fields, assist the grade 12s with bursary application and all of that. So it's always nice just to give back to the community, because it's always in my heart to share what I have learned with the future generation. So after assisting, I was assisting for almost 3 months. I was fortunate enough that the NRF offered me an opportunity to come here at to the University of Stellenbosch to assist with microcomputer tomography. So like I mentioned that I studied geology, but being a scientist, it means you are being taught to apply your knowledge in various fields. So this was more in the physics side. So I was like a bit, if I'm honest with you, I was a bit scared because I didn't know what I'll be doing. But I decided that, listen, if I don't take the step, or if I'm not confident enough to actually take the risk and actually learn, because I had an opportunity to apply geology into this emerging field in South Africa. So I took the opportunity, and I was under the supervision of Professor Anton du Plessis and Mr. Stefan Leroux, who is also a geologist. So I started in 2017. This was me, was very excited. One, because I was meeting one of the famous Egyptologists. So this is Salima Ingram. She's a famous Egyptologist that takes celebrities to see all the mummified beds and all the mummified kings of Egypt. So it was quite interesting to be able to see mummies your first few months of work. So it was quite interesting. So because I didn't know the technique, I would ask a lot of questions. If I don't know, I will write things down. It was always not perfect, but I stayed the course. And after a few months into my internship, I was then offered to become a research analyst or an X-ray CT analyst. And this is 2018 when I now officially started working as an X-ray CT analyst. And this was last year when we could take a picture without our mask. This is our new team. Mr. Stefan Leroux then got a job overseas, and now we have this new team where we have me and my boss, Professor Anton Duplessis, and we also have my colleague, Ms. Carlin Wells, who is an X-ray CT analyst as well at the facility. So I just want to, before I go to what I actually do for a living at the moment, I'd like just to share a video of our facility video.
Welcome to the Stellenbosch University CT facility. We are here to give you a virtual lab tour today to demonstrate all the non-destructive testing and 3D imaging capabilities available to you as a researcher or industry partner from all over the world. Please join me.
We're going to demonstrate the non-destructive capability by scanning this Kinder Joy to see what's inside without opening it.
The CT scanner facility at Stellenbosch University houses a walk-in cabinet micro CT scanner system for large samples as well as a nano CT scanner for highest resolution when using small samples. The micro CT scanner contains two X-ray tubes, one with a reflection type target and the other with a transmission target. Typical scan times are between 1 hour and 4 hours for this system, depending on resolution and quality requirements. I will be scanning a Mentor suite today so that we can see if there are any interesting features inside. The Nano CT instrument is well suited to small samples, and it is generally suggested that all samples of any material type smaller than 10 millimeters in diameter be scanned using the Nano CT instrument. This is our computer lab where our clients analyze their data in-house or remotely via TeamViewer. Volume Graphics VG Studio Max is our preferred software package, but we also have other 3D visualization software available.
So that is what I do for a living, but I'll explain briefly what X-ray CT is, what computed tomography is, and what we actually do with these machines, with these X-rays. So as I mentioned that I have a background in geology, I have learned to expand my expertise into physics, and I apply the technique in geology. So what is X-ray CT scanning? This is an industrial computed tomography. It's also known as macro CT or X-ray tomography or macroscopy. This is a high resolution 3D of imaging using X-rays. So essentially, this is a non-destructive technique where you can visualize your sample both outside and inside without destroying or opening it. As you saw with the example where we can take a Kinder Joy, see what toy it is inside without opening it. So it's very similar to the medical CT technique or medical CT. If you are familiar with it, with the medical CT, you would have a sample, a person that would be placed on the table, and the X-ray source will move around the person or the sample that is being scanned. And here you have the detector. However, with the industrial X-ray CT, which is what I do, the machine offers much better resolution, especially for smaller samples, and also offers more penetrative X-rays or high energy X-rays. So the difference is that here we will have the X-ray source that will project the X-rays through and around the rotating samples, and it will be collected by the detector. I will explain this in the later slides. So the advantages is that macro CT, it is non-destructive. So you don't have to cut your sample. However, it is limited to size. So it means we had a client who wanted to scan an entire leopard. Well, like it's too big, but we can scan smaller things like small lizards. We've scanned that before. Small concretes, we have scanned. Small trees, we have scanned that before. And you can record the sample particulars, I mean, inside and outside, without even destroying it. You can analyze different parts of the sample. You can visualize your sample in 3D. So what is X-rays? These are electromagnetic waves that have a wavelength of less than 1 nanometer. And they were discovered by a German physicist, William Conrad Roentgen, in 1895, and he actually tested this CT with his wife's hand. As you can see here, this is the first image that was produced with the X-ray CT, and he actually won a Nobel Prize in physics in 1901, first person to win a Nobel Prize in physics in 1901. So after the discovery of X-rays, the first tomography system was made in 1971 by Godfrey Houston and also Comrec, who produced the first prototype of an X-ray CT. And Godfrey is actually regarded the godfather of computer tomography, as is the first person to make the prototype of a CT system. And at the beginning, it was used for medical application to image people, to diagnose different diseases and stuff like that. But it was only in the late 1990s where the application developed into a more industrial application, like the non-destructive testing, where you would have to test if a sample that has been produced fits the quality assurance of the company. So the principle of X-ray inspection works in this way. You have an X-ray source that produces X-rays, and these X-rays are projected through and around a rotating samples. And some of the X-rays will be absorbed, and the absorption is influenced or determined by the atomic density of the material. And the attenuated X-rays will be collected by a 2D detector in a form of 2D projection images. After this acquisition of the 2D projection images, we then take the projection images to reconstruct the data set to make it a 3D data set that we can open in a 3D visualizing software where we can analyze. So how are these X-rays actually produced? So the X-rays, as I mentioned, that they are produced in an X-ray tube. An X-ray tube consists of a filament grid, a cathode target, and also consists of a voltage supply. So how it works is you have electrons that accumulate on the filament grid, and they will be accelerated towards the anode target by the voltage supply. And the interaction between the electron beam, the incoming electron beam with the anode target will produce X-ray in a form of Bremsstrahlung or characteristic X-ray or characteristic radiation. Now that we have the X-ray being produced, they will then be projected through and around our rotating sample that is put on or mounted on a stage. And when the X-ray or the incoming beam of X-ray interacts with the sample that we are scanning, some of the X-rays will be absorbed, and depending on the different atomic density, the absorption will be different. For example, if I give an example from a geology perspective, if we have iron that has a higher atomic density as silica, which is SiO2. So if we have a rock that is made of a silicate matrix, and we have some iron in it, because iron has a high atomic density, it will absorb a lot more X-rays, and then on our detector it will appear darker, and the silicate will absorb a lot less compared to the iron. Then it will absorb a little less, so the absorption will be lower than iron. And here, this is where we can see the different materials or the different components of our rock based on the atomic density that will result in different absorption. This is an example with a ballpoint, so this is a picture that we see on the detector before we actually reconstruct our data set. So here we have the ballpoint made of tungsten, and we have the spring made of, or the brass, which is made of copper and zinc, and we have the plastic. So here we have the tungsten that has a higher atomic density compared to the brass and the plastic, and because of this, we will have different atomic or different absorption levels, with the tungsten absorbing a lot more X-rays and appearing darker. So we can actually see where the ballpoint is and the shape, and then we will see the brass because it has a different atomic density compared to the tungsten and also compared to the plastic. So we'll be able to see the different materials. So there's a lot of applications that macro CT that it can be used to. It can be used as a non-destructive technique to actually see different particle sizes inside your sample, to calculate porosity, to see cracks in a concrete, to see to actually even measure the inside of a bottle, for example, without even like opening it. I will show some of the applications in the next slides. So this is an example in the biological or agricultural sciences. This is a live beetle. It was still alive when we scanned it, and the purpose of this was to study the anatomy of an actual live beetle. So instead of killing the beetle, we just sedated it so that we can actually scan. And after this, we're able to then see what the anatomy of this bee it is on the inside of this beetle on the inside, without actually dissecting it. So we can dissect it while we're analyzing, but preserve its life. So that is one of the awesome techniques, is that it is non-destructive. You don't have to kill or destroy your sample. This is an example in geology where you have a clay soil that has some barite veins, and they wanted to actually study the distribution of the barite vein. But because it's a soft rock, it's a clay rock, if we actually open it up or destroy it, it might break off this barite veins. So as I explained, that the different atomic density will then absorb X-rays differently. We have here this barite veins, and you can see that the matrix or the other parts of the rock have a lower X-ray density. That's why it appears gray. So in a sense, as I mentioned that previously, that in the 2D detector, the particle that absorb a lot more X-ray will appear darker. After the reconstruction, it's an inverse of that. So after reconstruction, what appeared more darker will appear very white on our histogram spectrum. So you have a histogram with a distribution of gray values from 0 to 65,000, 0 being air or void, and then a 65,000 being the material or the element that absorbed a lot more X-rays. So in this case, we have barite that absorbed a lot more X-rays, that here would appear more brighter than the clay matrix. So in this case, instead of breaking the rock apart, we're able to scan and then segment out the barite so that we can see the distribution of this barite inside of our rock. So this is a very nice technique that instead of breaking the rock apart where we would have lost what we actually wanted to study, we can then scan and reconstruct and actually see the distribution of our of the barite. This is one of my favorite examples, one of the best examples that we have. This is a mummified bird from Egypt, because if you've seen a picture of a mummified bird, or it will be wrapped in cloth so that it is preserved. So scientists nowadays, they want to study what is the animal that has been mummified. So instead of opening it up, we will then scan the entire mummy and then see what is inside. So based on the Egyptologists, they would say that depending on the different type of gods, for example, that they are sacrificing the birds to, they can actually see what's inside this this bird, because they would be fed before they are mummified for the specific objective of what they're being mummified for or sacrificed for. So a high resolution of the stomach of this mummy showed that this animals was fed different animals. As you can see, there's some teeth and some mandibles and some bones in the stomach of this mummy, which I find quite interesting. This is an example in engineering. So this is an example where one of our clients fell off a bike and hit his head on a rock and wanted to actually check if there's any damage on his helmet. So initially we scanned the entire helmet so that we can see if we can identify any defect by scanning the entire the entire helmet. And then after this, because we couldn't identify, he pointed the area where he fell on, and then we did a high resolution scan to see in more details if there's any destruction or if there's any damage to this helmet. So this is a high resolution of the suspected impact or the area of impact. And when we analyze, we realize that actually the helmet was still intact, which is a plus for the manufacturers, because even if you fall on a rock, the helmet will still protect you. This is an example again in engineering. This is a part that is used in the aerospace industry, in your rockets and stuff like that. So this is a part that is produced, and we actually analyze to see if the part was produced according to the dimension that was specified. So we can actually scan and compare the design and the actual object. And as you can see, the pink stuff represents some of the defect that occurred during the production. So you have a lot more materials on either side, resulting in this in this different colors. And the purple, for example, shows that there were not enough material on that specific place. So in this case, we can actually determine if the part that is being produced match the design that was specified initially. So this is another example where we scan the metal cast, where in this case, we can actually, if we want to see if there's any voids or there's any air bubbles or a defect inside of the cast metal, we can actually scan the entire metal, and we can actually quantify, and we can actually say, listen, at this part you have 180 millimeter squared void, and some of the pores are distributed in these areas. So for quality assurance, you can determine if it's good for use, or it will fail, or it won't last for a long time. So the good thing is you can actually even just slice through this cast material just to see exactly where this void or porosity, where they are based. This is an example with a wine bottle that, if I remember correctly, are used in the MCC industry. And in order to make MCC, they will need to rotate or to turn the bottle upside down. And they realized that there was some leaking with these bottles. And what we can do is, if the client gives us the specified dimensions that they specified to the people that produces the bottle, we can actually scan the entire bottle and go to the specific areas and actually measure if the bottle fits the the number that was specified before the production, so we can actually see if there's any deviation that might result in the leaking. And in this case, we actually did find that there were some parts that were not produced properly, hence leading to the leaking. Leaking when they are now making the wines. There's an example in the medical science. I also find this quite cool. This is a human femur where it was scanned to actually see what is inside, what are the structures that are inside. I mean, we can always see with a SAM or a very high magnified image, but how about if we can actually see with like what's inside the entire bone? So I actually find this interesting that you can see different structures inside that goes from different sizes depending on the on the area you are at the bone. This is very beneficial in the medical industry where they have to produce implants. If you broke your leg, they'll need if they need to make an implant, they will need to study the bone to see how it will actually fit and work. So this is quite interesting. I find it very cool. Okay, so now that I've shared what I actually do, like if you remember that I have a background in geology, so this for me was a bit of a scary field to step into because I didn't actually know and understand the techniques. However, over the years, I have put myself out there, and I have at this moment I have several papers that are published. So I'm contributing to the scientific world by publishing papers, some as the first author, some as a co-author, where I've contributed my ideas and some of the work. And this is a very good nice picture that I always look at when I want to remind myself of my goals or where I want to go in life. But this was a time where we were nominated for the NSTF Awards for the best data output facility. We were nominated, which is required, which is actually considered an award, because a lot of people, a lot of facilities in South Africa, they would submit their application. So we were fortunate enough that our lab was nominated. But looking at this picture, I just look at that little girl that was angry that she didn't graduate. But for me, this picture is a testament that if you have your goals, if you don't give up, if you try new things, if you even if you have fears and you actually go for your dreams, you can actually achieve a lot more. And last year, for example, I was invited to give a keynote presentation at the Science Day at Tembe Labs, which was for me quite it was very special to me to be able to actually sit down with other teachers, other scientists, and share what I do and how we can bridge the gap between the schools and the university, which is something that we actually need to do in order to grow our interest of science in from high school to university. And last year, September, I was invited to give a keynote presentation at the Global Conference of Tomography. So in my field, this is one of the biggest conferences where scientists go and share their work. And I was very honored to be invited to give a keynote presentation, and which was a very it was very special to me just to be on a global stage, on a global stage, sharing my work. And I was actually sharing my work that I'm currently doing for my master's degree, which is using the technique that I'm using to actually characterize macrofossil for petroleum exploration. So for me, it's a full circle that I studied geology and learned a new technique, and now I'm applying that technique to what I already know. I'll leave you with 4 things that have helped me growing up and also still learning as I grow in my career, since I've just started and I still have a lot more to achieve and a lot more to learn. These are some of the principles that I live by, that everyone, we need to make a choice to live a life of integrity. And what do I mean by that? It means that when you've made your choice for the career that you want to go for the life that you want to go for, which is actually very important, to actually write down your dreams, to write where you want to be, to aim to aim high, because the sky is the limit. To aim high, the sky is definitely the limit. But once you have that, it is to actually live a life of integrity, in a sense that we shouldn't betray ourselves, that the choices that we make once we have identified our decision, not to betray ourselves, to stay true to the course and to stay true to who we are. I mean, every one of us, we are special in our own way, and there will always be someone who's smarter than us, someone more beautiful than us. But it's at the end of the day, we choose ourselves to live a life of integrity, to say that if I don't know something, it doesn't mean I'm dumb or I'm stupid. It just means I can go and ask someone for help. And we choose to live that life saying, I won't betray myself and I will stay true to who I am and my integrity. To choose to pass wisdom. What do I mean by this? I mean that we all are from different environments, different households, different circumstances. And I always say that where you're from doesn't have to define who you are. And instead of choosing to pass your struggles, you choose to pass your struggles as wisdom, to say, I was here, but I choose to be here. So it means that life will always not be fair. There will always be someone who's from a better place or area or school than us. But we have to choose to say, where I'm from doesn't define me, and I'm choosing wisdom from what I'm learning from my circumstances in order to achieve my dreams. To take a risk. Decisions and choices are always difficult, and most of the time we will struggle with, what if I fail? But what if you don't fail? What if you actually do it? So I will encourage you that whatever your dream is, whatever you want to achieve, take that risk. Always have counsel from parents, from teachers, from good friends, whenever you want to make your decision. But stay true to who you are, to make your own choice, where you can ask advice from other people, but always stay true to who you are. And also choose wise words. What do I mean by this? It means that every day when you wake up, or whatever the situation is, choose words to speak to yourself, that instead, if I fail the test, I am not dumb, but I will actually do better next time. Meaning I'm not stupid, but I am intelligent. So it's to choose not to diminish ourselves by the words we speak, but to actually always, all the time, to say, I'm smart enough. And if I didn't make it this time, I will make it another time. And even if I fail the other time, I will try again. And the aim is not to give up. And this is what I want to leave you with, that I hope my story will inspire you to also achieve better dreams, to achieve your goals, to achieve whatever you've always envisioned yourself to be. Stay true to who you are, and you can actually do it. So this is because we are, the generation of Instagram. This is some of the Instagram posts that I always love to go back to. Is to always remember to follow accounts that will serve you in the long run. What do I mean by this? Is that on Instagram, we have a lot of things, Facebook, whatever, a lot of people that we can follow, but always have or follow accounts that will always remind you of your goals, so that when you log in and you're scrolling through your Instagram, that when you encounter those programs, they will always remind you of that dream that you wrote on your notebook, on that paper, to remind you who you are and where you actually want to go. And to also remember that what you feed your mind would lead your future. Like, what are we consuming on our daily basis? It means that we have to make time to read our schoolwork. We need to make time to actually empower our minds. I mean, we have YouTube, where instead of watching maybe all the time watching your favorite vlogger, you can watch one TED Talk that can actually encourage you when you feel discouraged. And also, it also leads into do something that your future self will thank you, to make wise decisions, to choose to be kind to other people, to choose to work hard all the time. And also remember that growth is the expectation that we have is that I will finish my high school, I will, and then go to university, graduate at the age of 22. Yes, it is possible, but it's not always the reality. You might encounter some obstacles along the way. But I've always said my motto is never give up. I have failed some of the courses in university. I've repeated some of the courses in university. I've written supplementary exam in university. I remember one year when I was in my second year, I failed. I think I failed 50% of my mocks. I mean, I failed 50% of my modules, and that when I got the results, I was so disappointed with myself. But I had to be truthful to myself to actually identify things that were making me not perform so well. It was hanging out with friends for long extended time, to sit in someone's room for until 4 a.m. You have classes at 7 o'clock. So some of the choices that I made at that time were not good. After that time, I made a promise to myself that I will never fail a module and I will never write a supplementary exam ever again. I told one of my closest friends to say, please hold me accountable to this. And I will tell you that after that, I never repeated a module. I passed. I obtained higher marks. I even remember in my final year, one of the lecturers were like, you've actually changed. But it was because I wanted to stay true to my word and to myself, to say I will never repeat a module again. And that has helped me in life to actually say, this is my goal. Even if I fail, I won't give up. So this is just something that I want to leave you with, and I hope it has inspired you to actually chase your dreams, to stay true to yourself and be kind to yourself and others. Thank you so much.
Wonderful, wonderful. Thank you so much. What a wonderful talk that we have got from our speaker, and we will now continue on the conversation from from the speaker's point of view. We will be starting our live Q&A session right now. Welcome once again to everybody that has joined us via the Facebook or the YouTube platform. We will now be speaking to Muofhe. As we introduce her, I will just hand over and just add it to this to our conversation now. So here we go. Good day and welcome, Muofhe, to our Let's Talk Science Women's Day edition, or Women's Month edition. Just want to just give you a round of applause. Thank you so much for all of the effort you have put in and joining us here today. We have a number of people that are watching us on YouTube and Facebook, as well as a few schools that we are going to be joining. So to everybody that's listening, my name, we'll just go around the room and we'll just have a way to just introduce ourselves, and then we'll also just say hi to some of our viewers that will be joining us. So from myself, my name is Hilton Tobias, and we'll go around the room quickly with some opening words, if that's okay.
Okay, good day, everybody. Sorry, Muofhe. I'm looking at my screen, so I'm trying to kind of follow some pattern. So it looks like I'm next to Hilton on the screen. My name is Yaga. I'm one of the facilitators on today's session from Itemba Labs. Thank you. Muofhe?
Thank you. Thank you so much for the introduction. It's actually my pleasure to share my story with a future female scientist. It's really an honor for me. So thank you for having me.
So thank you so much, Muofhe, once again for being here. We have got 3 schools with us at the moment. And I'm just going to just ask them just to wave, and then what we will do is we will get started with our question and answer session. So we've got Masibambisane. Hello, Masibambisane. Just give a little wave. We've got Jonga High School. And then also in the stream, we've got one of the schools, Hector Peterson, that is joining us today. And as soon as they've just given us a little hi, we will get started with our first question. So I'll hand over to Mr. Yaga to get started with our first set of questions, if that's all right. So, colleagues, welcome there, and we have everybody on screen. and we hope that they are able to hear us. So I will just kind of go ahead and see Jonga High School if they are able to hear us. Mm.
Yeah, they can hear.
Hi, Jonga. Wow, wow,
Okay,
wow.
all right. I'll take over without Hilton telling me to. All right then. Thank you, Hilton. All right, we'll go straight away to the questions, people. And first on the list of questions are questions from Jonga High in George. And I see Nsoko Tasisipo asked a question to Muofhe, and the question goes like, which is more harmful between a dentist x-ray and CT scans? And then I'll go to the next question, also from Jonga. And this question was asked by Zintle Chona. And it goes like, how many types of diagnostic image x-rays are there? At what point do they become destructive? Okay, let's stop there, Morphe. The floor is yours.
Okay.
Those are the first two questions.
All right, thank you for the questions. So I will ask the first one, which is which is more harmful between the dentist X-ray and CT scan? So they are both not harmful or painful at all, but they can just be uncomfortable when you're doing it. I mean, if you are getting your teeth X-ray, they will need to open up your mouth very wide, so that can be uncomfortable. With CT scans, I can imagine probably you are referring to the medical one. It's also not painful, it's just uncomfortable. And I think the second question from Zintle is how many diagnostic imaging x-rays are there? So there are quite a few. I think there are like 7 of them. We have the computer tomography, which is what where I work or what I work with, and we also have the fluorescence microscopy. We have the magnetic resonance. We have the magnetic resonance, the MRI and the MRA, and we also have the mammogram, the nuclear one, and we also have a PET scan and also plain X-rays. But these are just all of them, just in a broad term. So yeah, I think that answers the questions, I hope.
Okay, great. I see there's a request that we let the learners, if it's possible, ask the questions themselves. All right,
Okay,
on
that's
the
fine.
list was going to be Hector Peterson. All right, and according to the list, Sanelisi where Nkungwana was going to ask the question. So is Sanelisi were there to ask a question? Hector
Hi.
Peterson.
I think what we can ask them to do is just to unmute their microphone and then to kind of go ahead and ask their question from Sanelisiwe.
Okay, we're going to have to manage this. If there are some challenges, for the sake of time, we will proceed then and ask the question on behalf of Sanelisiwe. Sanelisiwe wanted to know, how were you encouraged to get into a science field correctly? I think that's very important, okay? And then she's also looks like it's the same person. Sanelisiwe also is asking, do you feel that you have equal opportunities amongst males as in the same field? Okay, I think those questions are clear. Thank you, Sanelisiwe from Hector Peterson.
Thank you for that question. So to answer the first questions, how was I encouraged to enter the science field correctly? So one was from my side. I've always been curious about things. I've always asked questions of how mountains formed, how do the galaxies stay where it is, the stars, everything. I've always been a curious child. So growing up, I always I knew that I would be in a field where it will allow me to ask questions and investigate to find the answers. And I was encouraged, or correctly, by just speaking to people that were already scientists, to ask how I can actually enter the field correctly, and what actually matches my curiosity. Because in science we have geology, we have chemistry, we have physics. Some are more interested in the chemical side, some are more interested in the rock side, like me. So after I had that curiosity, I had questions that I asked like future scientists scientists from my area, and they were able to advise me properly to or suggest that maybe I should look at geology. Then I went and checked what geology is on the internet, and that is now I'm a geologist. So yeah. I think the other question is, do I feel like there's equal opportunities as males? I'll say yes and no, but first, yes, in a sense that in science, for example, in this country that we live in, if you check most of bursaries opportunities, they advocate for females, especially Black females, to apply for scholarship. So I think they're trying to just to narrow down the gap between males and female opportunities. So first, I'll say yes, they are, and if we are like very serious about getting into the science field, there are a lot of opportunities for us as females that we can actually apply for those bursaries. In terms of being within the science field, I still feel that we need more females, and I'm counting on you, ladies, that you join the science field, and then we can actually narrow the gap between males and females in the science field.
Okay. Thank you, Muofhe. Masibambisane is next. Masibambisane, are you ready to ask your question?
Yes, we're just gonna need them just to unmute their microphones, and then they can go on with asking their question. Are we there? But I think perhaps now we will have to also continue on.
Okay, it's fine. It's not a train smash because we are reading what they would have asked anyway. All right. So I have a question here from Lilita Tungata, and she's asking, what is the difference between micro and nano CT? Then I have a question from Ntati Rabohome. What is the size limit of items that can be put in the micro CT? And okay, I'll take those two first because I think we've got about 4 from Masibambisane. Then I'll go on to the next 2. All right.
Okay. So the difference between micro and nano, it's in the size of the samples that we can scan. So I think I can combine these 2 questions because they are quite related. So with the micro CT,
Good
it's
afternoon, Professor and the
goes.
team. I'm not sure if you are able to hear us. The line is bad. Can you hear us, Mr. Yaga?
Yes.
Can you hear us?
Yes, we can.
We can hear you.
Okay, I think I'll just continue to answer the questions from the students. So the difference between micro and nano. So this is basically in terms of size. So the micro CT is mostly for bigger samples.
Mr. Yaga, can you hear us?
I think let's. We're just waiting. Muofhe,
Let me hand
apologies
over
for
to
the
my
disturbance.
learners.
Okay.
I think they might be
Good.
having some issues with the sound delays and so on.
Good morning.
Okay.
My name. I hope you had a great day today so far. My name is Lilita
There we go.
Tungata from Masibambisane High School, and my first question would be, what is the difference between micro and nano CT? Thank you.
Thank you,
Okay.
Masibambisane.
All right. Thanks, Lilita, for the question. So the difference between Okay, second question.
From Masbamisane. My second question is, what is the size limit of items that can be seen in microcity? And my third, how long does it take to become a geoscientist?
Okay, thank you.
Third question.
Greetings, Ms. Chibalanga. Our last question is, you have spoke about paleontology. Are there any difference between the bones of animals when compared to humans in a CT scan?
Okay, I
Thank
don't
you
know
very
if I
much,
should
Masipane.
answer
So,
those questions first. Okay, so the first question that was asked was the difference between the micro and the nano CT. I hope you guys can hear me. If you can, just give me a thumbs up. Masibambisane, hi. I think they can. Okay, I'll just continue with the answer. So the difference between the micro and nano is in the size. The micro CT is an in-house machine that you can actually walk into to put your sample, but then the nano CT is it's a small cabinet machine that you can't really walk into. So the difference is also in the in terms of the size that you can scan. So I will combine with the other question of what is the size limit that you can actually scan with the macro CT. So the macro CT, you can scan samples between 10 millimeters and around 300 millimeters in diameter, so they can actually the macro CT can take bigger sizes, whereas with the nano CT you can only scan samples that have a diameter of less than 10 millimeters, so so that you can get a very high resolution on the scan. I think the other question was related to paleontology. So the difference between human and animal bones. So I think the first thing would be the structure. Obviously, that the human bones and the animal bones have different structures. But in terms of related to X-ray, is that animal bones can are sometimes a little bit more denser than human bones. And from the video that you saw, where I showed a video of a femur that was rotating, you could see that the bone inside had a lot of porous structures. And with the animal bone, sometimes the porous structure can be a little bit less than the human bone. I think the last question was, how long does it take to become a geoscientist? So to answer that question, you need first just a 3-year degree to graduate as a geologist or a geoscientist if you combine it with geography like I did. And then after that, you can actually step into postgraduate or research in order to better your understanding, or to actually maybe narrowed it down to a specific field or application. Then you will do a one year of honors, and then after that you can proceed to do 2 years of masters, and to become a doctor for your PhD, then you can do it for 3 years.
Okay, thank you. We will also encourage other questions other than the ones that were in the list. So if any of the schools that are in the room, the learners have got more questions, not necessarily about the geology or whatever we are talking about now, any general thing that you want to ask our guest speaker, you are welcome to do so. Okay? So in the meantime, I'll go on to the general questions that were added, and I will try and read them in the manner that they've been written here. What are the risks of X-ray imaging? Can samples catch a light, I think, or be electrified? All right, as I've said, I'm reading it as it's been given here, but I think we get the essence of what the learner is trying to ask.
Yes.
Okay.
With micro CT, there's no risk. It's just only you are advised that when you put the sample in the sample mount, that whatever mount that you are using, that it's put tightly so that the sample doesn't move or fall out during scanning. But there's no damage to the actual sample that you are scanning. Hence, we call it a non-destructive technique. So yeah, it's not. There are no risk.
All right. Masibambisane Jonga, do the learners have some questions of their own that they would also like to add? Anybody can go.
My name is Onele. My surname is Ndoto. Greetings to all. I'm
Okay.
curious about the technologies that are used in CT scanners.
Can you
Technologies.
repeat the question?
I am curious about the technologies that are used in CT scanners.
The technology that is used in CT scan.
Yeah, I
Um,
think if I may add, perhaps what are the other things that you do with
oh,
CT scan, perhaps?
okay. So with CT, there's a lot of applications that you can use the technique. So it's basically a technique that you use in other fields. Like a few that I showed in my presentation. Like you can use it in biology, for example, in the academia side, you can use it in biology to image a biological sample. I think in the presentation, I gave an example of a beetle where they want to check the anatomy. So instead of cutting, they will actually just visualize the sample. You can use it in agri-science, for example. One of the recent example that we used was to scan coffee beans to actually check the structures inside, because that is important when they are roasting the coffee beans for production. Yeah, so there are a lot of applications. You can go to additive manufacturing. It's a new field where they print. For example, they'll print concrete instead of just making them. They'll print them, so they'll give it to us in order to actually check if there's any porosity, and if there's porosity, by how much. So I think just to answer this question is CT is the technique that can be used in a lot of fields that I can name them, but the list will be endless.
Okay.
Yes,
All
I
right.
think, Mr. Yaga, I apologize for coming in there. Perhaps I can also then go through to some of the audience members that are watching on Facebook. Please feel free to add any of your questions for Mr. Balanganda to the comment section. For me, I think I appreciate all of the answers. I think if I can ask one question myself, Chair, if that's fine. My question would come to one of the questions is there are there any type of materials that cannot be imaged at all using a CT scanner in kind of in the industrial process?
Yes, that's a good question. So, I think during my presentation, I mentioned that in order to see contrast between the materials that you're scanning, the X-ray absorption increases with increasing when the atomic density increases. So, a metal like tungsten, it's actually very difficult to image. It causes a lot of streaky artifacts. So that is one of the examples that is very, or one of the material that is impossible to image.
Okay. Does it happen quite often, or I'm
Um,
just thinking.
Uh, so this is a coincidence actually. I had a client bringing a tungsten metal. It was quite big. They wanted to image. So with that we can make a way in terms of we can maneuver the settings a little bit, like increasing the voltage so that the X-ray absorption is actually a little bit higher. So with that, we just advise them to cut the tungsten into a smaller size so that even when we are rotating to 90 degrees through the longest axis of the sample, we can still get some X-rays through so that we can image. So yes, things like liquid, for example, it's quite difficult to scan. We had a client bringing lizard and snakes that were in alcohol. So yes, we have different types of things that people bring. So with that, when the liquid moves, it causes some blurriness during scanning. So so those are the things that sometimes like we can't image, even if we can like optimize the settings, sometimes it's impossible.
Yeah.
It's obviously
Thanks.
dead when it comes to you, eh?
Yes. Yes, especially the snakes. I don't, you know.
Yeah, for sure. All right,
Yes.
thanks. I want to put myself in the shoes of some of the learners that are here. So I will pretend that I am a girl in grade 10 or in grade 11. And I want to know how do you overcome challenges of growing up in a city, you know? Because, for example, a lot of the schools that we have, that we interact with, are not schools from rural places.
Mm-hmm.
I'm talking about a place like George, for example, that's not rural.
Mm-hmm.
Delft in Cape Town. Okay, so what are the challenges that you think girls that are in that setting could face, and how could they go about tackling those challenges that makes them not to succeed, in life
Okay.
generally? Yeah.
Okay. I think this question it's a good question. Although I'm from a rural settings, I've lived in cities for quite some time, and I find that living in cities, one, there's a lot of advantages than disadvantages. But some of the disadvantages, I would think there's a lot of things to do that can derail um, our focus on on our schoolwork.
Mm.
But as someone who grew up in the village, I wouldn't know what are the specific challenges that girls that grow up in the cities have. But in terms of just to maneuver the question around, I would say living in cities or in towns is actually uh, it's actually very nice because you have exposure to a lot of fields and industries. Like you can go to towns and see different companies,
Mm.
whereas me from a rural setting, you only hear. So what's good with cities is that you can hear and also see different companies, or you can even see successful people, because that's also something that when you're from, for example, for me being from a rural area, you only have a few people that are successful that you have. But if you're from town, you can actually see a lot more successful people, and maybe you can make that your goal, that one day I would want to be that person. But in terms of challenges that we face as girls, I think both in rurals and in townships, I think they're all the same, but I would just say it's only up to us to identify what's important for us so that we don't derail in our dreams. And yeah, I think I will just put it that way.
Thank you. Any other question from the learners themselves? I'm sure there might be a lot of things that they would like to ask Muofhe.
Yeah.
Anybody from Masibambisane, Jonga, who wants to also ask something else? Okay, while they are getting ready to formulate question, I've got another question.
Yes.
I heard in the talk that you went from Venda to Nelson Mandela University to Stellenbosch. Any particular reason that you chose Nelson Mandela Bay? Because I know, for example, that one of the most distinguished professionals from Venda, Prof. Zwindini, is from Venda.
Yes.
Could it be
Yes.
that he's the dean in that university that you went there? Yeah.
Um, okay, I will answer it this way. So when I moved from Venda, went to the University of Free State to do my first year there.
Oh, okay.
But I was there. I experienced a few challenges being from a village, not speaking a word of Afrikaans. That was a bit of a
Mm.
barrier for me. So I decided to move to a more English university, and I went to Nelson Mandela. That was the reason why I moved from Free State to Nelson Mandela. But the reason why I went to the University of Free State, it was because some of the some of the females in my area had went to the university to study geology. So for me, it was like, okay, I would like to go to that university. I didn't have knowledge of how many other universities were there, but so we only from my high school, you have UCT that comes, UP, yeah, Stellenbosch not even, but a few universities that they do come to the school and present them. So one of the university as well was the University of Free State, and I actually took interest. So when it comes to Prof. Azwi, he came to PE when I was doing my honors, and yeah, he has become
Okay.
more like a mentor as well.
Okay.
So yes, yeah.
Oh, thank you. Thanks for that. Okay, I'm sure Masibambisane Jonga, you must be having some questions. Ma'am, teachers, you are also welcome to enter the conversation. All right, I see somebody's getting ready from Jonga. Jonga, you can ask your
Mr.
question.
Yaka,
Yes, ma'am. Yes, ma'am. Masibambisane.
oh, now, Mr. Yaka, we don't have any questions on our side.
Okay. All right. Okay, thank you, ma'am. And then Jonga.
It can be any question.
Yeah.
I'm happy to answer.
How can you improve the reliability of the CT scan?
The availability, that's a good question.
Yeah.
We need people like the government to give us money to have a lot of X-ray CT. However, we've had the challenge of because CT is not even like in undergrad. A lot of people don't use the technology. So we are currently working on just having like conversations like this to actually explain to people what the technology is about, and maybe then we can also go to different high schools to actually show what CT is and what it can do. So in terms of availability, I know in South Africa we only have three facilities, and they're more used by industry and also in academia. So we are working on increasing the availability so that even like high school students can actually see and know what CT is. I only knew about CT when I was about to start my internship, which was quite late.
Okay. All right. Ma'am, Kubanto, you have some question there. I saw you are next to the computer.
Do you have any questions? Oh no.
Okay.
I think if I'm not mistaken, Chonga High School perhaps had another question. I think there was a hand at the back of the room. Oh, no.
Buzani Betunana, don't be shy to talk. This is your platform. This is your time to engage with Muofhe. And as you can see, even in the age gap, she's not that very far from you. So,
Yes.
yeah, you
So
can
ask any
relate to her.
question.
You can ask her anything. Okay. And I'm sure you've got lots to ask. Okay. Even if you're not comfortable in English, you can ask it in Xhosa, then we'll do the interpretation. Okay. So you can ask anything to the speaker. Okay.
Is there anything you can improve in your CT scan?
Okay.
In terms of machine wise, there are quite a number of CT that are produced by different companies, but what I would improve is to have a bigger machine that can scan maybe samples that are more than 300 millimeters in diameter. And the machine that we have here, the micro CT, in terms of energy, it can go to 240 kilovolts. So increasing that might be another option, but there's a lot of restriction in terms of the technology regarding that. But there are some machines that can scan up to I think 500 kilovolts, but they're very expensive because the micro city we have here was about 12 million rent. So it's quite expensive to actually buy the state of the art. We do have the state of the art, but I mean to have maybe higher specs like voltage, it's a bit it's more expensive.
Okay. You may have answered this question already. I see a question from Masiba Mbisane. What are the requirements needed for the course?
Is it for geology or for micro CT? Because with micro CT, you don't study to become an X-ray CT analyst. You just get trained. So I would say having a degree in science and an interest in X-ray imaging.
All right, good. And I
But I
think
think,
one
no,
of the I was
sorry,
going to say
mm,
the basics for them as learners would be to do well in
yes,
mathematics and physical science. That's the gospel truth. Unfortunately,
yes.
you have to start there. You have to start doing well there as well. But my other question, which as again, I try my best to put myself in the shoes of these learners that don't want to ask questions here, even though I know that they've got a lot of questions. The issue of money is what drives young people to want to stick with education or not. What would be your take on where you are at the moment without revealing any numbers? Would you say it's a comfortable space for a person to start, having these material things that we so require all of us, and buy your car, buy your house, or stuff like that? What would be
Yeah.
your comment around that?
Yeah, so the field that I'm in, as a young 27-year-old, it's comfortable to to buy the material things, but I think one of the big motivation that motivates people in choosing careers is how much I'll be paid. And I always say that sometimes passion is more fulfilling than material possession, or maybe it's just me, but also the material possession do come along the way. So my first thing would be to do what you love, to follow your passion. And I mean, in science, if you're a researcher, you will get a comfortable, you'll be in a comfortable position to buy your car, to buy your house, and whatever phone or whatever material things that you wish to have.
Thank you. Looks like there's a question from Jonga. Go for it, Jonga. Okay.
What legacy do you want to leave behind as a scientist?
Okay.
That's a good question. Something I've been asking myself lately. That anything is possible. That is my legacy. That because as a young female scientist, there's a lot of barriers that you can experience. Sometimes you ask yourself, "Am I good enough to be in this field?" Because it's very male dominated. And in South Africa, not a lot of black females are in the industry. But from someone who's from a background that I'm from, I would like to leave a legacy of saying anything is possible. If you can look at my life and my achievements, it's all because of hard work. So my legacy would be that everything is actually possible. That is my legacy that I want to leave behind.
Okay. All right. I'm going to throw this question to the girls themselves. I want the girls to share with us what is it that is the main challenge when they are at school. What makes them have or experience any hardships to be at a position perhaps where Muofhe is at the moment? What sort of obstacles do they face? Can anybody from Jonga or Masibambisane answer me there? What are your challenges generally as people, as young people, as young learners? You know, what stops you from achieving at school? It can be anything. Share anything. This is your space. Okay. Is anybody willing to come and say something?
Peer pressure.
Peer pressure. Okay. Peer pressure. Muofhe, are you able to say anything about the issue of peer pressure? It's
Uh,
actually one of the main challenges I know.
yes, peer pressure. It's also a main challenge as young adults as well, even
Mm,
after high school. But how I define peer pressure is doing what other people are doing. And you have to ask yourself, do I really want or do I like doing what other people are doing? Peer pressure never ends. In high school, it's trends that people are following. Um, when you start working, it's people buying cars and you're thinking maybe I should buy my car. So peer pressure never ends. So I think as young learners, you just have to make a decision of do I start living life according to other people's expectation or what they want, or do I want to do my own thing that I know? I think I highlighted in the presentation that one of the things that will center you is to write your goals down and your vision, like where do you want to see yourself? And if there's something that you are or you want to do because other people are doing, ask yourself, will this help my future self? Because like I said, peer pressure never ends. So it's actually advisable to start looking at like now where you are to say, do I really want to do what other people are doing? Just because it's nice and trendy at the time that is being done. So yeah, make your goals and stay true to them and ask yourself if things that you like that other people are doing really fits into your vision and goals.
mm, good point. Thank you, Muofhe. Any other comment from you guys? In other words, if you think it's cool to go out and take substance into your body, just because everybody is doing it, it's not necessarily the case. Okay,
Yeah.
where will it lead you? Where will it take you? Okay, think about your future. Think about your goals. Think about the fact that you want to have a stable life later on in life. So if you indulge in stuff like that at an early age, where will it take you to? Okay, so these are the type of things that you need to think about as young people, and that not because it's done by everyone else. As I said, it means therefore I also need to do it. No, it's not necessarily the case. Okay,
Professor and the team,
Masibambi-san, it
we are
looks like
very
you are ready.
grateful for this opportunity. It was wonderful hearing about geoscience, and we are grateful for everything. Thank you. Bye. See you next time.
Okay, all right,
Bye.
thanks. It looks like Mami Basani has to go. All right, thank you, guys. We appreciate your presence, and we appreciate the fact that you participated in the events. Thanks so much to you as well. All right, all right. Want to hand over to Hilton, and it looks like we basically would have come to the end of the line without
Yeah,
really
maybe
realizing that,
yeah.
because I see, yeah,
Maybe before Hilton goes, I'll just
yeah.
maybe would like to say this that one thing that helps in life is to just go for it, like not being shy to say what you want, or even ask what you want. That is one thing that in life it does, it helps. So if you know you want something, go for it. If you are uncomfortable with something, say it. If you want to ask something, because if we live life where we are shy, we won't reach our, like I always give this example to my younger siblings, that if you have a question, in even in class, and you don't ask, no one will know you are struggling with a certain part of your schoolwork or even certain part of your personal life. If you keep if you keep quiet, no one will know. But in life, it's about stating what you want exactly, and that will help you in life just to have more people that can share their wisdom with, and also just for you to improve yourself as a young person, to always state what you want and voice exactly what you really want.
Sure.
Wow, I think the amazing words that has come out from this conversation is something that will perhaps strengthen these learners, and provide them with some aspirations, and some goals. I think that was, I think, perhaps part of what we were speaking about, is to set yourself some goals, and stick to them. From my side, I really appreciate the being on with us today, Muofhe, and to all the schools, Chonga High School. I think Masibambesane has left the stream now, as the school day has continued on. They've set aside some time to join us, and we appreciate them being on the call in the room with us today. Chonga High School, all the way out in George. We appreciate them also, and all of the questions that they have brought in. I don't think I will touch on too much, too much else. We've had Hector Peterson High School as well, and another school, Utola High School, that have been joining in. But I feel uh, they've gained something from this conversation. It's just a pity that there was a little bit of connection issues, so they were breaking in and out of the room. But we really appreciate all of the words that you've shared with us today, Muofhe, as well as to the program director. I think I might just add him in there, Mr. Yaga. Thank you so much for facilitating the conversation, and I think we appreciate everything that everybody has done, and I think we will sign off. And I think we've done a few of the last words. If there's nothing else from Jonga High School, maybe we'll give them one last uh, time for them to just kind of sign off and say goodbye to Muefe, and to thank her for her time. Maybe, guys, you can just give us a wave then, uh, and just say I say I think yeah, I'm sure they've enjoyed everything that was said, and everything that was shared with us today. Thank you so much once again from our side. From We really appreciate it, and I think we will look forward to our next session, when we have another Let's Talk Science session. We hope to engage with the audience again. So thank you to everybody that is watching on the Facebook page, as well as on the YouTube platform. We appreciate everybody watching up, and we hope that you would keep your eyes open for our next session. And thank you so much, everybody. Just a round of applause for everybody at this point in time.
Mm.
Thank you,
Thank you very
guys.
much.
All right.
There we go. And from there, I think we will close this room. We will close this session. And if there is any questions that the schools have afterwards, I'm sure we can take them, and you can send that to us via your educators. And we also want to thank the educators that are in the background facilitating the conversation as well. So thank you very much, colleagues. Thank you very much, friends. May you all have a good day further. Thank you very much.
Bye.
Bye bye. Bye.
Ma'am, bye bye.